The practice of digital India, machine learning. What is machine learning? Machine learning teaches computers to do what comes naturally to humans and animals, that is, learn from experience. Machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. The algorithms adaptively improve their performance as the number of samples available for learning increases. Machine learning algorithms find natural patterns in data that generate insight and help you make better decisions and predictions. They are used every day to make critical decisions in medical diagnosis, stock trading, energy load forecasting, and many more. Media sites rely on machine learning to sift through millions of options to give you song or a movie recommendations. Retailers use it to gain insight into their customers' purchasing behavior. Machine learning, real world applications. With the rise in big data, machine learning has become particularly important for solving problems in the areas such as computational finance for credit scoring and algorithmic trading, image processing and computer vision for face recognition, motion detection, and object detection, computational biology for tumor detection, drug discovery, and DNA sequencing, energy production for price and load forecasting, automotive, aerospace, and manufacturing for predictive maintenance, natural language processing. Machine learning uses two types of techniques. Number one, supervised learning, which trains a model on known input and output data so that it can predict future outputs. And second one is called unsupervised learning, which finds hidden patterns or intrinsic structures in input data. Supervised learning. The aim of supervised machine learning is to build a model that makes predictions based on evidence in the presence of uncertainty. A supervised learning algorithm takes a known set of input data and known responses to that data output and trains a model to generate reasonable predictions for the response to a new data. Supervised learning uses classification and regression techniques to develop predictive models. Classification techniques predict discrete responses, for example, whether an email is genuine or spam, or whether a tumor is cancerous or benign. Classification models classify input data into categories. Typical applications include medical imaging, speech recognition, credit scoring. Regression techniques predict continuous responses, for example, changes in temperature or fluctuations in power demand. Typical applications include electricity load forecasting and algorithmic trading. Using supervised learning to predict heart attacks. Suppose clinicians want to predict whether someone will have a heart attack within a year. They have data on previous patients, including age, weight, height, and blood pressure. They know whether the previous patients had heart attacks within a year. So the problem is combining the existing data into a model that can predict whether a new person will have a heart attack within a year. The second type of techniques used in machine learning is called unsupervised learning. Unsupervised learning finds hidden patterns or intrinsic structures in data. It is used to draw inferences from data sets consisting of input data without labeled responses. Clustering is the most common unsupervised learning technique. It is used for exploratory data analysis to find hidden patterns or groupings in a data set. Applications for clustering include gene sequences analysis, market research, and object recognition. The successful application of machine learning technique depends on choosing the right approach. Choosing the right algorithm can seem overwhelming or daunting. There are dozens of supervised and unsupervised machine learning algorithms, and each takes a different approach to learning. There is no best method or one size fits all. Finding the right algorithm is a partly just trial and error. Even highly experienced data scientists can't tell whether an algorithm will work without trying it out. But algorithm selection also depends on the size and type of data you are working with, the insights you want to get from the data, and how those insights will be used. When to use machine learning? Consider using machine learning when you have a complex task or a problem involving a large amount of data and lots of variables. but no existing formula or equation. For example, machine learning is good option if you need to handle situation like the following. Machine learning can be used in the following context, assuming that you have handwritten rules and equations that are too complex, as in case of face recognition and speech recognition. Machine learning can also be used in a context where rules of a task are constantly changing, as in fraud detection from transaction records. Another context where machine learning can be used is when the nature of the data keeps changing and the program needs to adapt, as in automated trading, energy demand forecasting, and predicting shopping trends. Machine learning real world examples. Example number one, creating algorithms that can analyze works of art. Researchers at the Art and Artificial Intelligence Lab at German University wanted to see whether a computer algorithm could classify paintings by style, genre, and artist as easily as humans. They began by identifying visual features for classifying a painting's style. The algorithms they developed classified the styles of paintings in the database with 60% accuracy, outperforming typical non-expert humans. The researchers hypothesized that visual features useful for style classification, a supervised learning problem, could also be used to determine artistic influences, an unsupervised problem. They used classification algorithms trained on Google Images to identify specific objects. They tested the algorithm on more than 1,700 paintings from 66 different artists working over a span of 550 years. The algorithm readily identified connected works, including the influence of different painters, paint of Pope Innocent X on Francis Bacon's study after Hvac. Another application of machine learning in real world is about optimizing HVAC energy usage in large buildings. The heating, ventilation and air conditioning HVAC systems in office buildings, hospitals and other large-scale commercial buildings are often inefficient because they do not take into account changing weather patterns, variable energy cost or buildings' thermal properties. Buildings IQ cloud-based software platform addresses this problem. The platform uses advanced algorithms and machine learning methods to continuously process gigabytes of information from power meters, thermometers, and HVAC pressure sensors, as well as weather and energy cost. In particular, machine learning is used to segment data and determine the relative contribution of gas, electric, steam, and solar power to heating and cooling processes. The Building IQ platform reduces HVAC energy consumption in large-scale commercial buildings by 10 to 25% during normal operation. Another real-world application of machine learning includes detecting low-speed car crashes. With more than 8 million members, the RAC is one of the UK's largest motoring organizations, providing roadside assistance, insurance and other services to private and business motorists. To enable rapid response to roadside incidents, reduce crashes, and to mitigate insurance costs, the RAC developed an onboard crash sensing system that uses advanced machine learning algorithms to detect low speed collisions and distinguish these events from more common driving events such as driving over speed bumps or potholes. Independent tests showed that RAC system is to be 92% accurate in detecting test crashes. Summary: Machine learning is a new computing application that helps people make informed decisions by analyzing large data sets and by suggesting trends and detecting events.